Hello everybody. So today you're starting your lesson on solving quadratic equations by factoring. And last unit we spent the entire unit on all the different forms of factoring, using GCF, using grouping, where A equals 1, A does not equal 1, and difference of squares. So now you're going to take all of that knowledge from last unit and you're going to apply it to solving quadratic equations by factoring. What that means is once you get your binomials after you factor, you're going to set each binomial equal to 0. So looking at this worksheet, the worksheet starts off where it's already factored. 1, 2, 3, and 4 are all already factored. You do not have to factor those, okay? So all it's wanting you to recognize is how you set each binomial equal to 0 and solve for the variable. So I really like how this worksheet started, just so you can understand where you're wanting to go in the end. So once you factor, you end up with two binomials. Those two binomials are set equal to 0. Once you get to this point, you are going to take k plus 1 and set it equal to 0. And you're going to take k minus 5 and set it equal to 0. And this just becomes a one-step equation to solve for the variable k that we've been doing all year long. In order to get k by itself and solve for k, you're going to subtract 1 from both sides. When you subtract 1 from both sides, you get k equals -1. If I have k minus 5 equals 0, I'm going to add 5 to both sides, and I get k equals positive 5. So the two values of k that would make this set of binomials equal to 0 true would be -1 and 5. And you can go back and check your answer. Let's plug in -1 for k here and 5 for here. Substitute it in and see if it becomes true. If I have -1 plus 1, that would be 0. Anything times 0 is 0. If I have 5 in this binomial, 5 minus 5 is 0. Anything times 0 is 0. So I know that my two answers, -1 and 5, are true. So let's go down to number 3. I'm going to try to leave it, oh yeah, it's going to work perfect, to where you can see the steps from number 1. So just like we did in problem number 1, you're going to set each binomial. Sorry, my cat was playing with a toy. It was driving me crazy. Okay, so you're going to set each binomial equal to 0. So binomial number 1, 4k plus 5 equals 0. Binomial number 2, k plus 1 equals 0. So now I want to solve these two equations for the variable k. In order to solve for variable k of this equation, I'm going to subtract 5. This becomes a two-step equation. When I subtract 5 from both sides, I'm left with 4k equals -5. This is multiplying. The inverse operation of multiplication is division. So in order to get rid of that k to solve for k, or get rid of the 4 to solve for k, I'm going to divide both sides by 4 and get k equals -5 over 4. You can leave this as a fraction. You can change it to a decimal. It doesn't matter. And then this one over here, the one step is super easy. You just subtract 1 from both sides. It's just a one-step equation. So k equals -1. So those are how you solve when you're already given the binomial. Number 1 and number 3. Number 2 and number 4 are done exactly the same. Number 2 is done exactly like number 1. Number 4 is done exactly like number 3. Number 2 is just a one-step. Number 4, both of them become two-step equations where you would solve them like this here. And number 4 will end up having both of the values as fractions or decimals, however you want to leave it. So now let's go on down to number 5. Let's look at number 5. This should look very familiar to you. Number 5 is a quadratic equation that is not factored. You have to factor it yourself to get your two binomials like number 1 and number 3. So on number 5, the first thing before you start any quadratic equation by factoring, you've got to make sure this is taken care of and moved over to combine with your C value. Okay, you cannot have a -5 lingering out here. This needs to be 0. You've got to set your two binomials equal to 0. So the first thing we want to do is add 5 to both sides, and I'm going to combine that with my C. I'm going to combine that with my C. Okay, this is kind of like combining like terms. I'm going to add 5 to 19. That's my like term. Positive 19, positive 5 are like terms. My quadratic equation then becomes x squared minus 11x plus 19 plus 5 is 24 equals 0. This is where you want to end up with factoring. Okay, so just like last week and the week prior, last unit, you're going to factor out x squared minus 11x plus 24. First thing you need to do when factoring is look for any GCFs. In this problem, we have 1x squared minus 11x plus 24. For this particular problem, there is nothing that will factor out of each 3 of the terms. Can't factor out an x because this term doesn't have an x. And there is no common factor between 1, 11, 24. So I'm going to leave it the same. I'm going to leave it alone. Don't do anything to it. So a equals 1. That's the coefficient in front of x squared. B equals negative 11. That's the coefficient in front of x. And C equals 24. That's the coefficient that's at the end of my quadratic. This is an A equals 1 problem, so I do not need an AC for this particular problem because A equals 1. Okay? So now you need to set up your T. I'm going to come over here in this blank spot over here. Let's set up our T. In our T, I know that C goes over here, B goes here. My C is positive 24, and my B is negative 11. What are my factors that would multiply to 24 but add to negative 11? So the factors of 24 are obviously 1 and 24. 2 and 12. 3 and 8. And 4 and 6. As I've stated before, you do not have to list all of them. If you can look at these two numbers here, these two integers, and you can automatically tell me what two numbers multiply to be positive 24 but add to be negative 11, you can skip this entire step. That's great. If you can look at this quadratic without doing a t-table, that would be wonderful. Or a cross, as we've been calling it. So if you're doing the cross, both of my factors need to multiply to be a positive, but add to be a negative. If I know they need to multiply to be positive but add to be negative, you should know that both of your factors should be negative. A negative times a negative is a positive, and a negative minus a negative, or a negative plus a negative, is always a negative. So negative 1 minus 24 will be negative 25. Negative 2 minus 12 is negative 14. Negative 3 minus 8 is negative 11. Negative 4 minus 6 is negative 10. So by looking at this cross, I know that my two factors are negative 3, negative 8. Negative 3 times negative 8 is positive 24. Negative 3 minus 8 is negative 11. So my two factors are negative 3, negative 8. So I can come over here, and my two binomials are x minus 3 and x minus 8. So once I get to this point, I'm going to solve it just like I did for number 1 through 4. Set each binomial equal to 0. X minus 3 equals 0. X minus 8 equals 0. When I add 3 to both sides, I get x equals 3. Add 8 to both sides, and I get x equals 8. I'm running out of room, so I can't write that step, but hopefully you all can see that. X minus 3, you add 3 to both sides and get 3. Add 8 to both sides and get 8. All right, so let's skip on down to number 9. Numbers 6, 7, and 8 are done exactly like that. Exactly like number 5. So I'm skipping on down to number 9 because there's something that we have to do on number 9. Okay, so on number 9, the very first step that you should do is look over here and make sure that my quadratic is set equal to 0, and it's not. So I need to move this positive 6 over to combine it with the like term, which is negative 18. When I subtract 6 from both sides, my new quadratic equation is 6n squared minus 18n minus 24 equals 0. Now I can factor this out. The very first step in factoring is look for GCF. Look for your greatest common factor. In this case, I have a GCF of 6. 6 will divide into 6, 18, and 24. So I'm going to factor out a positive 6, and that leaves me with n squared minus 3n minus 4. From this step, I'm going to pull my a, b, and c inside the parentheses. A equals 1, b equals negative 3, c equals negative 4. So I'm going to come over here and I'm going to draw my cross. My c value is negative 4. My b value is negative 3. My factors of 4 are 1 and 4 and 2 and 2. Both of my factors need to multiply to be a negative, add to be a negative. They need to multiply to be negative, add to be negative. So just by looking at multiplying to be a negative, I know that a negative times a negative is a positive, and a positive times a positive is a negative. But a positive times a positive times a positive is a positive. But a positive times a negative is a negative. So I know one of these numbers needs to be a negative. So if you don't know the trick, you would have to rewrite this. Well, you can only write 2, 2 once. You don't have to write 2, 2 twice. So I don't know if 4 or 1 is negative, and then you just make one of the 2's negative. But if you know the trick, then you would know what set of factors are your factors for this problem. So let's check it. -1 plus 4, that's positive 3. -2 plus 2 is 0. 1 minus 4 is -3. So I know that my two factors that multiply to be -4 but add to be -3 is 1 and 4. So if you knew the trick, you knew this a couple seconds ago. If B is negative, C is negative. If both are negative, the negative goes with the larger number. And you could have eliminated some steps here. So coming back over here, I need to draw my two binomials, set it equal to 0. My two binomials are n plus 1, n minus 4. Because I had a GCF of 6, I cannot forget my GCF out in front of my two binomials. Do not forget your GCF in front of your two binomials. That makes a huge difference. So coming over here, I'm going to have to write on the side of my paper here. We've got 6, m plus 1, m minus 4 equals 0. So in order to find my n values, first thing you need to do is set your GCF equal to 0. 6 equals 0. Does 6 equal 0? Absolutely not. This is not for number 10. This is not for number 10. This is a continuation of number 9. I just ran out of room on my paper. Does 6 equal 0? No. So eliminate that. N plus 1 equals 0. Subtract 1 from both sides, and I get n equals -1. N minus 4 equals 0. Add 4 to both sides, and I get n equals 4. Now this is very important that you pay attention to and you do not forget your GCF, because you could very well end up with a GCF with a variable. Let's say this was 6n. You factored out a 6n, which could very well happen. Then you would have 6n equals 0. Then that would mean that n equals 0. That's why you always want to set your GCF also equal to 0. That way, if you have a variable in your GCF, you don't accidentally forget. Okay? So that is, how many problems did I do? 1, 2, 3, 4. That is 4 examples of your 10 problems from solving quadratics by factoring. Okay? So now for classwork/homework, you need to do 2, 4, 6, 7, 8, and 10. If you have any questions, get with a partner or ask the sub if you have questions. Bye, y'all.